Okay, now we're here to try to solve problems. But before we solve them, we need to have some tools. The obvious tool we need is a calculator. The second one is the periodic table, because in some cases you will be asked to look up molar mass. The third thing, we have a PDF that has the pressures, temperatures of all these equations in this rearranged form, so that you can see if there's a problem that you have, how the problem should be looked at. Okay, so let's look at this first problem. First problem is, what is the mass of 2.5 liters of sulfur dioxide at STP? Okay, based on the previous video, first thing we need to do is select an equation. We already know what equation we're going to use because the question is mass. But if you're not sure or uncomfortable with that, look at how many pressures, temperatures, and volumes. There's only one, which means we have to use this equation. All right, now the next part of it is, let's load the data on this side so we have the right information in the right section. So the first thing is pressure. When we say STP, we mean 1 atmosphere. Volume, 2.5 liters. That goes here. Mass, well, there's nothing here for mass. The default is going to be moles, because later on I will show you. Next thing is R. Well, R is the universal gas constant. 0.082 atmospheres or liters, degrees Kelvin, divided by degrees Kelvin. Last one is temperature. Well, STP. Temperature is going to be 270 degrees Kelvin. Sometimes it said 0 degrees centigrade. What I'm doing here is automatically using that equation that we talked about in the previous video. Now we have the data. We know what we're looking for. We're looking for N. Now we rearrange the equation. That's what the equation looks like rearranged. Now we plug in the values. Okay, 1 atmosphere is P, 2.5 liters is V, R, which is this, is 0.082, and temperature, which is this, is 273 degrees Kelvin. And we now put in our calculator and we get a number, 0.112. That still is not grams, but we have another equation, which is moles is equal to grams divided by molar mass. Well, we just have calculated the moles. We're looking for the grams, and the molar mass is associated with sulfur dioxide. What is sulfur dioxide? It is SO2. You now go to the periodic table and you find that S is 32. We have 2 oxygens, 16 plus 16. That gives us 64. We solve for X, and it's 7.15 grams. Okay, that's the first problem. Now let's go to the second problem. Second problem, let me read it to you, is a 5-liter volume of ethane gas is heated from 290 degrees Kelvin to 596 degrees Kelvin. If pressure remains constant, what is its final volume? Well, we automatically know we got 2 temperatures. We really have 2 volumes. That tells us we need to do the combined gas law. This is the combined gas law. So that's the first step. The second step is we now need to take the data from the problem and put it in our data table. Okay, so let's go. Now, there's no rhyme or reason why I'm picking T1 as 298, except it's the first one that I see. So this is going to be T1. And this is going to be T2. Technically, I could have done it in reverse, but I'm a person who reads left to right. Okay, now, this, a 5-liter volume of ethane is heated from 298. That means 5 and 298 are together. So that's why V1 is 5. So we draw another line through here to V1. The next thing is pressure remains constant. What does that mean? It means pressure 1 equals pressure 2. So therefore, there's going to be no change in pressure. This equation implies a change in pressure. When there is no change in pressure, these two are eliminated and you get this new equation. Okay, now what are we looking for? Volume. So now we rearrange the equation to have the volume. We put in the appropriate numbers. Again, 5 liters, 596, and the appropriate temperatures, and we get V2, which is going to be 10 liters. Okay, for the next problem, if 7.75 liters of radon gas is at 1.55 atmospheres and minus 19 degrees centigrade, what is its volume at STP? Again, automatic flag. STP, temperature, pressure. That means we have 2 temperatures and 2 pressures, which means we use the combined gas law. So again, we set it up with the appropriate formula. Next step is to make sure we tag the data to match up. So in this case, I'm saying this is going to be V1. Okay? It says this is at 1.55, so that means this has to be P1. Okay? And at minus 19, so this is going to be T1. However, it's at centigrade. Remember, this equation only works if it is in Kelvin. So we use the formula, which is minus 19 plus 273, and then we get 254 degrees Kelvin for this temperature. So this temperature cannot be anything but Kelvin. Now, we have additional data, STP. That means, and we're going to call this P2 because we've tagged everything as P1. P2 is 1 atmosphere because we're doing STP. We're looking for V2, and the temperature, because it's STP, is 273 degrees Kelvin. Okay, now we've done the second phase. The third phase is rearrange the equation. This is the rearranged equation. Again, we have a PDF handout that you can look and see how we rearrange it. Next one is we put in the data. 1.55, 7.75, 254, which are the appropriate ones. And now we put in, stop it. Yep. Well, that rearranging took its toll. How's that? Do me a favor, Stephanie, just redo this to make sure I get the number. T1 is 254, and this is 273. When I do it this way? Yeah. Okay, let me see if I put it in right. P1, V1, T2. Hmm. V1, P1.